Hi everyone, we are from group 20. Today we will present about independent random variable. This is my group member. What is independent random variable? Generally, in probability theory, two events are independent, statistically independent or stochastically independent if the occurrence of one does not affect the probability of the other. Similarly, two random variables are independent if the realization of one does not affect the probability distribution of the other. What is independent event? We recall to definition 15, which is two events A and B are independent if probability A intercept B is equal to probability A times probability B.
From definition 25, independent random variables is two random variables x and y defined on probability space omega set A probability and taking value in measurable space EB are independent if for any pair AB in B square, the event inverse x of A and inverse y of B are independent. The triple omega set A P probability is called a probability space. Then event omega's sure event empty set the impossible event. Let A be a tribe on omega. Let omega equal to real number. The smallest tribe containing all open intervals is called the Borel tribe on omega and denoted by Br. It is commonly used tribe when one deals with real number or on interval of real number. As it is a tribe, Br also contains all countable unions of open intervals, all closed intervals, and more generally all the subset of the real line we need in a financial model. Diagram for the independent random variable x and y in B square. Prove that x and y are independent. x1, y1, x2, y2, x2, y1, and x2, y2. Thus, any pair AB in set B square.
As you can see, it is the relationship between image of A and x inverse of A through the measurable function of x. For the omega prime space of A to the omega is equal to x inverse of A through measurable function of x inverse. On the other hand, for the small omega of W to the omega's prime space is equal to measurable function of x. It is the same speculation occur for the B. Then this is we can see that the mapping of omega prime to omega is a random variable on a countable space. For the x inverse and the y inverse of A in B in the omega is in the omega prime of A and B through the measurable function of y inverse and x inverse respectively.
The event inverse x of A and inverse y of B are independent, so you can prove it by definition 15. How to determine whether it is independent random variables? The preproposition, which is the two random variables x and y, are independent if and only if the generated tribes bx and by are independent. Consequently, knowing y doesn't change the probabilities of the events in bx. The same arguments could be applied by exchanging the roles of the two variables.
The values of x and y are not fundamental. What is crucial is the information revealed by the variables. If x and y are independent, it's also for the case for ax and by, where a and b are non-zero real numbers. This is a diagram for independent random variable Sn. 2y in the set B square. So as you can see, the coefficient of y is 2, but they are still independent. It's also the same case for the diagram for independent random variable 2x and y in B square. And the coefficients for x variable is 2, so they are still independent. So that's all for our presentation and video. This is our group member and is our reference that we are using, and the end. But okay, private. Okay, the end. Bye bye.